We're going to go over a lot of cool stuff for math. We've got Brandon Kraft on the line here.
Hey, everybody. How we doing?
Good. And probably many of you are familiar with Brandon's videos. If you haven't watched his videos, we'll definitely pull up those resources where you can find him on YouTube and his website. And before we get into that, I just want to give a quick introduction of myself and Brandon. My name is John Wynn. I'm the founder of Smart Edition. And we started in about 2018. Started with a study guide that is available on Amazon and our website. And that has just really evolved over time to become an online courses and practice test packs and things like that. And really where I began the company was with my wife, Melissa, who's a pediatric nurse practitioner. And many years ago, about 2013, 14, she went to go into nursing school and had to sit for the entrance exams and just a lot of challenges in getting prepared for it. And I had worked in test prep publishing for about 20 years. My family owned a company. So we kind of put our heads together and started Smart Edition and started out with all the different nursing entrance exams, the TEAS, the HESI, Kaplan nursing entrance exam. And so that's kind of where we are today. And along that timeline, I crossed paths with Brandon probably 2 or 3 years ago, and have kind of been partnering up ever since then. Brandon's done a lot of math videos for us. He's helped us even develop some of the math questions and helped us proof them and do all sorts of stuff. So he's been a great partner for us. So that's myself and Smart Edition. I want to turn that over to Brandon, and if you want to give a quick intro of kind of what you're all about. And
sure, man. Yeah, so I'm Brandon Kraft. If you have seen my TEAS math resources, you're familiar with bcraftmath.com. A little bit about me. I'm not a business owner, so to speak. I'm a solo math instructor, married, have one son. Well, I guess you could say we have two with the dog, but my wife said she is the president of the One and Done Club with kids. So we have a redheaded boy. I've been teaching math for 15 years professionally, high school for 4, and I've been teaching college level mathematics for 11 years now. But I'm 35 years old. I would say ever since I was in elementary and middle school, I was building that teaching habit of helping people, and ultimately it turned into my job. Other things about me real quick. We love to host parties, have friends over, cookouts, all that good stuff. But yeah, I mean, I love math so much. I mean, check it out. That's my license plate. That's advertisement for you too. I mean, so I'm known in the little town that I live in. It's only about 50, 60,000 people, but everybody knows me as the math guy. So
he's
a little bit about me.
He is the math guy. Cool. And that is, how can students work within those time limits and solve problems faster? Are there certain types of math problems that there are little tips and tricks and things that you can do to solve them quicker? And so Brandon had a bunch of examples. So he's got those up on the screen. So we're going to take the next 10 minutes or so, and he's going to walk through a few problems and show you some of those tips and tricks for little shortcuts for how to answer these a little bit faster and make sure that you're not running up against your time limit when you actually take the test.
All right. Well, thanks, John. So here, what I want to go over with you, I got 5 examples, and this is very similar to what I do in my TEAS live sessions or in my TEAS videos as well. So the things we're going to look at, a question I see a lot, people are concerned about with the way they set up a proportion. Other things that I want to show you too is, yes, we can use some shortcuts with fractions by converting those to decimals. That's going to be the second example. Reading a word problem, and sometimes I find myself jumping straight to the question before I read a paragraph of math stuff, and I'll explain that when we get there. PEMDAS, I see this a lot popping up in Facebook groups where people get, I mean, there's a long thread of comments where people are kind of saying it's 1 or it's 25, and I want to make sure we can answer that correctly. And then the last one here, understanding decimals when you're dealing with time, length, and weight. So we'll come back and finish up with that. So proportions is different than something you may have heard of called dimensional analysis. And that's something I don't want you to worry about for the TEAS. That's something you're going to do in geometry, and you will ultimately do it in med dosage. But for TEAS, a good chunk of problems can be solved using proportions. So a quick example here, a child weighs 25 pounds. Given that 2.2 pounds is approximately equal to 1 kilogram, how much does the child weigh in kilograms? So I'm going to show you 2 ways, and there's actually 4, 5, 6, 7 different ways you could actually set up this proportion. One thing I'm going to do is I'm going to look for my conversion, or hopefully at some point, especially when y'all hit med dosage, this is a conversion you want to know. 2.2 pounds is approximately 1 kilogram. And what I'm going to do is I'm going to write 2.2 and I'm going to put it over 1. This is just one way to set up a proportion. I'm going to identify what 2.2 stands for. That's going to be our pounds. And then the 1 kilogram goes down here at the bottom. Now, some of you may not set it up like this, and that is fine. But again, there's multiple ways. So over here on this side, a child weighs 25 pounds. Since I put pounds over here at the top, I want to put pounds over here at the top and look at what the question is saying. How much does the child weigh in kilograms? So we're trying to find kilograms, and that is this missing spot. Now, I'm not going to solve this yet. I'm going to go ahead and set it up a slightly different way, and I want y'all to see, yes, it will look different, but we'll still get the same answer. So suppose I set it up like this. 1 equals 2.2. Now, what in the world did I do here? Well, I'm still using that conversion, 2.2 pounds, 1 kilogram. I'm setting it up totally different, but let's just recognize now that this number represents kilograms on the left and 2.2 represents pounds on the right. This is totally fine. I know it's completely different than what I did over here, but notice now the 25 pounds, since I have pounds on the right, I want to put the 25 pounds over here on the right-hand side. And we're still trying to solve for kilograms, so I'm going to throw my X down here. Now, assuming that you are somewhat comfortable with proportions, I like to go through this in a speed way because we are all about trying to save time. Now, please don't set up 2 different proportions on the TEAS test, but what we can do here, we can cross multiply. And what I want y'all to think about is when we cross multiply here, for example, this example, we're going to take 2.2 times X. Well, notice we're going to take 2.2 times X over here on this side as well. If we look at the other cross product, 1 times 25, it's the same thing. It just looks different. It's all about putting them in the same spot. Either put pounds at the top, kilograms at the bottom, or set up your kilograms on one side and your pounds on the other. Now, from here, I did mention that question earlier. What number is going to get multiplied by X? It's going to be 2.2. Well, that's the number you immediately want to divide by. So cross multiplying 1 times 25, that's just going to give us 25, and immediately divide by the number getting multiplied by X. So I'm going to go ahead and divide by 2.2, and there we have our kilograms. And obviously on the TEAS, you will want to round that. Let me get my calculator back up. So somewhere around 11.4 kilograms, give or take, depending on what it tells you to round to. But my point here is this. Just because you don't see a proportion set up the way you did it, that doesn't mean that you did it wrong. That's the point I want to get across here for that one. Now, I want to go ahead and jump into some other tips too. People struggle with fractions. That's one of the most common things I hear students say that they are not comfortable with. Well, sometimes with fractions, you can convert these to decimals, but be careful with the long decimals. So 2/3, and something you want to go ahead and tell yourself right now, if you did not know this, to convert a fraction to a decimal, we just take the top number divided by the bottom number. So 2 divided by 3, we get 0.6 repeated. And don't worry about that 7 on the end. The calculator is just rounding. But what I'm going to do here is I'm not just going to write 0.6. I'm going to write a bunch of them down. This is what I mean by being careful. And let's repeat the process for 5 divided by 8, or 5/8. Now, this is going to be a nice decimal, and we get 0.625. Now, some of y'all may be doing this entirely different. Some of y'all may be saying, okay, I'm trying to find the sum, so you know that you want to add these together. And maybe you're saying, okay, I know how to get common denominators, but some of us don't. And that's the point I want to get across here, a way that we can take advantage of these multiple choice answers. So This decimal right here, I'm going to actually type that in. I mean, I'm just going to type in a bunch of sixes. It don't matter how many, just put a bunch of them up there. And since we want to find the sum, I'm going to add on the 0.625, which is that 5/8. And this is where you have to be careful, folks. That decimal right there, we want to find the fraction that is the closest to it. The closest to it. And see, some of y'all might be thinking, okay, 1.3. Well, let's be careful. 13 over 10. If I take 13 divided by 10, that gives me 1.3, but this is not 1.3. It's close. I admit that. So let's see if we can get a little bit closer. 131 divided by 100. That's 1.31. Okay, I don't want to mess with that. Let's try 6 divided by 5. That's 1.2. So right now you're thinking it's still going to be 13 over 10, but check this one out. Check out this last one. 31 divided by 24. That is pretty doggone close. I mean, the only thing here on my calculator is I don't have the 7 on the end. So yes, you can take these ugly decimals, these long decimals, and you can use them. And you don't have to use them when you're just adding things or subtracting things or multiplying or dividing. You can even, if you practice enough, I don't really recommend it, but I have seen people use them in solving equations. I really don't recommend that, but yes, we can take fractions and convert those to decimals. So I'm going to jump on into the, now, by the way, this is getting recorded, so we're going to share this video again at a later date. I know I'm kind of going through this fast, but when it gets recorded, you can pause, slow it down, what have you, and hopefully these tips will help. So this one here, jumping straight to the question in a word problem. I mentioned that earlier, and here's why. If I skim the question, it says right here, how many students are in the class? So I'm already kind of keeping that in the back of my head. How many students are in the class? How many students? Okay. Now ratios, ratio of boys to girls, the order does matter. Boys is first, girls is second. Therefore, the 2 represents boys and the 5 represents girls. Sorry about the background noise. If you can hear that, we have a big dog barking, but boys to girls, 2 to 5. So 2 over 5. I am setting up this ratio as a fraction. The 2 represents the boys. The 5 represents the girls. So kind of going back to proportions, you know, so here I got boys up top, girls down here at the bottom. If we set this equal to, well, let's see what we have next in the problem. There are 30 girls. So since girls was down here, I'm going to put the 30. And what are we going to be finding here in this proportion? This is where you have to be careful. The only thing I'm solving for is the number of boys. Now, if we cross multiply and divide, remember that quick way. Go ahead and ask yourself, what number is going to be multiplied by the variable? The 5 is. That's what you're going to want to divide by. So let's go ahead and multiply the 2 by 30. That's going to give us 60. Immediately go ahead. Don't waste time. Don't write this down. You need to get these seconds back. Immediately divide by 5 and we get 12. Here's the deal though. You see that answer choice, yet maybe it's still kind of lingering in the back of your head. How many students, not how many boys. So this is just the boys. We need to add on those 30 girls. Whoops. 30 boys, add on the 12 boys, add on the 30 girls. We have a total of 42 students because it said how many students are in the class. So don't let that one little itty bitty word there cause you to get this one wrong.
Brandon, so is that like really paying attention to that last part? What's the actual question asking? Yep. and not getting caught up in the first part of it and just looking for a ratio?
That's exactly right. Yeah. So sometimes jumping to the question, whatever that question's asking, is kind of sticking in the back of your head, perhaps. It says how many students. It didn't say how many boys. And a lot of people will get that B equals 12 or X equals 12. And they're like, oh, I see that answer. I'm going to pick it. And then that could have been easily been a problem that you could have gotten right instead of you got it wrong.
So is there anything for that? I mean, just make sure you're rereading the question once or twice, or the last part of the question, to make sure you're really understanding what exactly it's asking for before making your selection and moving to the next question.
Absolutely. And that's something that I find some people don't do. They're like, they see an answer and they jump to that one. And I understand why. I mean, you're in this time crunch and you see an answer, you're like, oh, I got this right. But yeah, if you can sacrifice a few more seconds and go back and read it again, even after you read it first. How many students? Yet all we know here is boys, so we had to add on that 30.
Yeah, that's tough. You're trying to move as fast as you can, but that's how you get tripped up, by moving too fast.
Absolutely.
Yep. Okay.
How's the comments looking?
It's good. Everybody's dropping their answers here, and there's quite a few people who had A. 12 is the answer.
Yep, and I see somebody over here in mine that says, darn, I would have chose 12. And it's funny, I was doing this problem yesterday with a group of students, and it was very similar example, and they picked the boys or instead of adding them together. So I'm glad that I think that's going to help quite a few folks out. Sweet.
This is good. It's good to make the mistake one time and also know why you made that mistake and why you should not make it again by taking that time to slow down and make sure you're answering what the question is asking.
Learning from them here.
Yep.
Now, this one here, so it's which one's the answer? And if you're going back and watching this video later, or if you're watching it right now, I'm going to go ahead and tell you, I don't know who told some people this, but evidently a lot of people have been told that we're always supposed to multiply before we divide. I have never said that to a single student in my life. Multiplication and division, they both hold the same weight. And it's all about which one comes first as you move from left to right. That's what it boils down to. So do them from left to right, whichever comes first. Now, before we dive too deep into that, let's make sure we take care of our parentheses in this problem. So yes, I am going to go ahead and work the parentheses out. So 3 plus 2, we get 5. Now, something else to take note of, if you don't see an operator in between, like this 4 and this parentheses, automatically that means multiply. And I'm seeing comments over here. People are already saying 25, and that's good. I can't tell you how many times I've been tagged in Facebook posts, and I love being tagged. I don't care about that, but people get, back and forth. What we have to do here, since division comes first from left to right, we want to take care of that division before we multiply. So 20 divided by 4, do that first. We get 5, and then we can multiply by 5 to give us that answer of 25. Whereas, if we mess this one up, I'm going to rewrite it. 20 divided by 4, and then we have our 5. Go ahead and get that out of your head, folks. We do not multiply first here. And if you did, look at what you get. If you'd be like, okay, I know I'm going to multiply. That's 20 divided by 20, and that gets 1. And I think that's what led to a heavy discussion every time I see this pop up, is because you're getting 2 nice answers. But the correct answer here is definitely going to be 25. So don't do it that way.
So there's a right and a wrong way to do this.
Absolutely. And if I pulled up like a scientific calculator or a graphing calculator where you can type in, the TEAS calculator, it kind of stinks because we can't type in an entire expression all in on one line. And on scientific calculators and graphing calculators, you can type in this whole daggone thing at one time, and it's going to spit out 25. Or heck, if you just go type this in at Google, type in 20 divide 4 parentheses 3 plus 2, it's going to probably spit out, well, it should spit out 25. Obviously, these are 3 different types of measurement. 2.5 hours. That's what that really says. 2.5 hours. But what I see people say, and I'm going to go ahead and say, no, it's not 2 hours and 5 minutes. It's not 2 hours and 50 minutes. It is, so yes, 2 hours and 30 minutes. And you may be thinking, okay, I got that. I understand what you're saying. Just in case you don't, and I'm going to slap another one up here right here in a second. We know we got 2 whole hours. What I want y'all to look at is that 0.5 is really like 50% or half. 50% and a half mean the same thing. So if I want to take 50% of an hour, but yet I want minutes, I'm going to take 50%. You can type in 0.50 or 0.5 of multiply 60 minutes. And if I do that, we're taking half of 60 minutes, which is the 30 minutes. With that same concept in mind, let me just come down here, and it applies the same concept to feet and inches, pounds, and ounces, but we're using different numbers. But let me throw this one at you. Suppose I had 3.75 hours. This is not 3 hours and 75 minutes, because then you would be over 4 hours. And this is what I see people do. So 3 hours, 75 minutes, no way. My pen's getting, I need to replace that, but it'll be all right. So 3 hours, 75 minutes. This is not correct. What we're really thinking about is 3 whole hours, and then we're going to take 75% or 0.75 of 60 minutes, because 60 minutes are in an hour. And if I bring that up, let's find 75%. By the way, the percent key, let me tie that into here. I'll type in the 75 and then bang on that percent button, and look at what it did. It converted it to its decimal form. So 75% of 60 minutes, we get 45. So therefore, 3.75 hours is 3 hours and 45 minutes. Because 45 minutes is 75% of an hour. It's 3/4 of an hour. I mean, all this lingo that people say, it's quarter till, stuff like that. I mean, that same stuff is applying here. Now, to kind of bring all this to a conclusion, the 2.5 feet, that's not going to be, I just want to go ahead and put the nose up here. It's not going to be 2 feet, 5 inches. That 0.5 is 50% of a foot. So the answer to this one, if you take 50% of 12, this 0.5, I'm going to be taking 50% of 12 inches, because 12 inches is what makes a foot. So the yes answer to here would be 2 feet and 6 inches. And then this last one down here, we're going to take 50%. Yet again, all these are 0.5s. So 50%, but now since we're talking about ounces, we're not dealing with 60 minutes in an hour. We're not dealing with 12 inches in a foot. We're dealing with 16 ounces in a pound. So therefore, number 3, 2.5 pounds is going to be 2 pounds, and 50% of 16, or half of 16, we get 8 ounces. But you can do the same thing with these other decimals, 0.75, 0.8, 0.9, point whatever. Multiply it by the number of minutes in an hour, inches in a foot, or ounces in a pound, depending on the problem that you're dealing with. And that is my spiel.
Awesome. That is tons of good info. I think everybody is really appreciating everything here. And